Very good morning students. Welcome to the another video of online classes. Till now we have completed chapter 1, chapter 2 and chapter 3. Now we'll start our chapter 4 which deals with the refraction of light at plane surfaces. Okay, let us begin with one. The contents in these chapters are refraction of light, laws of refraction, speed of light in different media and relationship between refractive index and speed of light. Then we have principle of reversibility of the path of the light. Then we have experimental verification of law of refraction and determination of refractive index of glass. Then we have refraction through a rectangular glass slab. Okay, and the last part which is omitted uh, from your previous year syllabus, okay, that we will not learn in this video. Okay, so let us begin with the first. Before going to the lesson, I think you all have an idea about the speed of light. So speed of light in different medium, it is given here. So the speed of light in vacuum is 3 into 10 to the power 8 meter per second and approximately equal to in the air medium also 3 into 10 to the power 8 meter per second square meter per second. But in water it is little less, it is 2.25 into 10 to the power 8 meter per second. For glass also it is less than water, 2 into 10 to the power 8 meter per second. So mainly the refraction of light is deals with and it is depending upon the speed of light in different medium. As the speed of light is different in different mediums, that's why it will show a refraction of light. Okay, let us begin with the topic, the refraction of light. Okay, the bending of an oblique ray of light when it passes from one transparent medium to another transparent medium, different optical densities, is called refraction of light. Okay, suppose we have two mediums, air and glass. We know that in the two different mediums the speed of light is different. So when a ray of light is passing from air to the glass medium, then it will bend. Okay, so how it will bend, we will see the that one after this slide. Okay, so now the refraction of light means what? When the bending of beam due to the light travels from two different medium. Okay, one medium to another transparent medium, so it is called as the refractive index. Then we have the refractive index of light, sorry, the refraction of light occurs because light travels with the different speed in different media. So we are already discussed about this. Now then the refraction of light is a surface phenomenon. Okay, and on the boundary separating the two media there is a partial reflection and a partial refraction. Okay, suppose we will take, suppose this one is the surface. Okay, a light beam is incidentting on in this direction, then there will be a partial refraction through this one is refraction, and a partial reflection will be like that. Okay, this one is reflection and this one is refraction. Okay, that's why the boundary separating the two media, this is air and this is water. Okay, so when a ray passing from air to water, then it will at the separating boundary of two media, and that means at this surface there is a partial reflection here. This one is partial reflection and this one is partial refraction. Okay, then we have in the refraction of light from one medium to another medium due to change of speed of light, the wavelength and intensity of light changes. Okay, the wavelength and intensity of light changes, but its frequency remains constant. So you have to remember that when a light passing from one medium to another medium, its wavelength and intensity remains light changes, but the frequency remains constant. Okay, now when a ray of light is traveling from a rarer medium to a denser medium, then what will happen? The it will bend towards the normal. Okay, let us have a eye on this figure. Okay, so this one is incident ray and this one is the surface. This one is this above surface is air and the below surface is glass. Okay, now this is the incident ray and this is partially reflected ray. Okay, and this one is partially refracted ray. If you will take these two mediums are same, then the incident ray should be this one, the dotted line. But as these two are different mediums and it is passing from rarer medium to denser medium, you know that air is rarer and glass is denser medium. So when a ray of light is passing from rarer medium to the denser medium, then it will bending towards the normal. So this one is the normal and the incident ray actually have to be go through this line, but it is bent towards the normal. Okay, so this one is normal, so it is bent towards the normal. It will bend towards the normal. Okay, so then we have when a ray of light from a denser medium to a rarer medium, then it bends away from the normal. Let us look at the figure. Okay, so when a ray of light incident here, then the actual path should be this one if these two mediums are same, but as there are two different mediums and the light passing from denser to rarer, then it will move away from the normal. So this one is the normal and it is moving away from the normal. Okay, so you have to remember these two for our ray diagrams also. Okay, then this one, if a ray is incident normally on a surface, then what will happen? It will pass undeviated. That means, see, this one is the surface, whatever may be the media, whatever may be the medium, whether these two are rarer or denser or from denser to rarer, that doesn't affect. If you incident and a ray normally 90 degree to the surface of normally, then it will pass undeviated. When that means it do not have any refracted angle and the refracted angle R should be 0 here. Okay, so here the ray passing through this line only, so it is undeviated line. Okay, then we have laws of refraction. Okay, the incident ray, it has two laws. The first one is what? The incident ray, the normal at the point of incident and the refracted ray all lies in the same plane. Okay, this one is first one. The incident ray, the normal at the point of incidence and the refracted ray all lies on a same plane. Then the second one is what? For a given pair of media and for a particular color of light, the ratio of sine angle of incident to the sine angle of refraction for for all values of angles of incident is a constant quantity. Okay, so what does that means? If and that is called as the constant quantity is called as refractive index of second medium with respect to the first medium. Okay, so we can have a little bit more idea about the two. The second law, see this one, it is given the ratio of sine angle of incident ray. That means if I is the incident angle, then sine angle of incidence to the sine angle of refraction. So here sine I by sine R. Okay, so this is a constant quantity when there is a refraction of light is there. Okay, so now we'll have how to know, and this constant is known as refractive index. Now we'll have if a ray of light travels from A to glass, then what will happen? So it can be written as like this: A to glass means A mu G, because refractive index is given by mu and this is called as mu. Okay, A mu G, that means refractive index of glass with respect to air. This is the meaning of A mu G is what? Refractive index of glass with respect to air is equal to sine angle of incidence divided by sine angle of refraction. Okay, where A mu G is called the refractive index of glass with respect to air, and this is the mathematical form of the second one, the second law of refraction. Okay, and this is given by the Snell. That's why it is also called as Snell's law of refraction. Okay, I hope you understood this one. If you have any doubts about regarding this, then you ask me. Okay, then the next refractive index. Okay, so from that we can define refractive index as the second medium with respect to the first medium. Okay, the refractive index of second medium with respect to the first medium can be defined as the ratio of sine angle of incidence in the first medium to the sine angle of refraction in the second medium. Okay, so there is a note, as these two are same and similar quantities, that's why the refractive index has no units. Okay, the refractive index has no units. This is important. This can be a 1 mark question also, important 1 mark question. What is the unit of refractive index? So refractive index is a unitless. We can say that is a dimensionless also. Okay, so the refractive index has no unit because it is a ratio of two similar quantities. Okay, so now some other valuable things we will know about the refraction of light. Okay, so effect of speed v, frequency f, and wavelength lambda due to refraction of light. Okay, let us have an eye on the point wise. The first one is what? When a ray of light gets refracted from a rarer to denser medium, the speed of light decreases. Okay, you know that in rarer medium the speed is more, in denser medium the speed is less. That's why when a light goes from rarer to denser, the speed of light will decrease. While if it is refracted from denser to rarer, the speed of light will be increased. Okay, this is reciprocal to that one. Okay, then it is vice versa. Then the second point is what? The frequency f of light depends on the source of light, so it does not change on refraction. Okay, if there is a change in refraction, if the change of frequency is only depending on the source of light, whether that is if the source of light changes, then the frequency will change, but it is does not depending upon the refraction. Okay, so frequency will remain constant, remains unchanged in a refraction process. Then the third one is what? The speed of light v in a medium is related to the wavelength lambda, and the frequency as v is equal to f lambda. Okay, this one is important, you have to remind this one. Okay, then we can write lambda is equal to f by v also. Okay, as v is equal to f by lambda, we can write lambda is equal to v by f. Okay, velocity of speed of light by f, frequency. And when a light passes from rarer medium to denser medium, the wavelength also decreases. Okay, since the speed of light decreases, that's why wavelength is also decreases, but the frequency remains unchanged. The frequency remains unchanged. And when the light passes from denser to rarer medium, the wavelength increases due to the increase of speed of light. And here also the frequency will be remain unchanged. Okay, so thank you for today's class. In the next class we will have the remaining topics. Till now, have a nice day. Thank you.